Okay, class, we continue our topic of discussion under work, energy, and power with some questions to be solved here. Okay, we have the first question that says a stone of mass 6 kg is released from a height of 30 meters. Calculate the figure 1 potential energy, figure 2 velocity before impact. We're now asked to take g to be equals to 10 meters per second square. Now, solving physics question, the first thing to do, we write out the given data, meaning what we are being supplied in the question. So from the question here, we have the mass m equals 6 kg. We have the height h equals 30 meters. What we have to find is the potential energy. Potential energy has the symbol PE in physics. And what is the basic formula for potential energy? Potential energy equals the product of the mass, acceleration of free fall due to gravity, and the height, meaning our PE equals mgh. We supply the given figures. We have our m to be 6, multiplied by g to be 10, multiplied by h to be 30. When we punch our calculator, we have 1,800 joules for the potential energy, because energy is measured in joules. That's why we have 1,800 joules. Let's take the second question under question number 1. But before we do that, you must take note that what? Energy can never be destroyed nor created, but energy can be transformed from one form to another. Okay? So in that case, it means the potential energy that the body has will be equal to the kinetic energy. Okay, the potential energy that the body has at rest will be equal to the kinetic energy that the body will have while in motion. Okay, and what is the formula for kinetic energy? Kinetic energy equals half mv squared. We input the formula there. Our ke equals to what? Pe, and Pe equals 1,800 joules. So we have 1,800 joules equals half multiplied by m is 6 divided by b squared. When we cross multiply, we have 6b squared equals 1,800 multiplied by 2. V squared equals, when we divide, we have 600. So ordinary v will be equals to root of 600, and that will give us 24.49 meter per second approximately. The unit of velocity is meter per second. Question number 2. We have to compute the power output in watts of a machine that lifts a 50 kg crate through a height of 20 cm in 1 minute. Take note, class, while solving questions in physics, the basic unit, meaning the SI unit, is very important. Okay, the SI unit of height or distance is always what? Meters, and the SI unit for time is always what now? Seconds. So which implies we must convert that 20 cm to meter, and we'll convert the 1 minute to seconds. So let's give the data supplied. Let's list them out. We have our power, as what we have to find unknown. We have the mass equals to 50 kg. We have the distance equals to 20 cm. Height is the same as the what? The distance. And 20 cm being converted to meter will give us 0.2 meter. That is 20 divided by what? 100. And that will give us 0.2 meters. Our time t equals to 1 minute. 1 minute in seconds equals to 60 seconds. What is the basic formula for power? Power equals to force times distance all over time. Okay, so there, what is our force? Force is mass times g. That is mass times g, mg, multiplied by the distance. So from there, we put our figures given. M is 50, g is 10, our d is 0.2. Take note, g, whether it is given or not, we take it to be what now? 10 meters per second square. Okay, the g has a value of 10 meters per second square, or 9.8. But if it's not given, we use 10. Okay? So we have 50 divided by 10 divided by 0.2 divided by what now? 60. So punch our calculator, we have 100 all over 60. 100 divided by 60 will give us 1.667 approximately in watts. Okay? So we have a question to be solved here. The third question will be the question that I would like the whole class to attempt. Okay? So I'm giving you the options there. A is 100 seconds, B is 150 seconds, C is 175 seconds, D is 200 seconds, and E is 250 seconds. What is the question? A 50 kg man climbs a building at a rate of 3 kJ per minute. What is the time to reach the top of the building in 20-meter high? Okay, so a 50 kg man climbs a building at a rate of 3 kJ per minute. What is the time to reach the top of the building 20-meter high? I wish you best of luck. Thank you very much for listening. I will see you in the next class.